Welcome to section 8.3, adding and subtracting rational expressions. So in this section, we're going to have a lot of similarities between rational expressions and fractions. So remember, when we are adding fractions like 6/7 plus 3/7, we have to have the denominator be the same. All right, so here we have the common denominator 7. And so we can think of this as adding sevenths of a pi, right? So if we had 6/7 of a pi and 3/7, we're going to end up with 9 parts, 9/7. So with fractions, we keep the same denominator and we perform the operation to the numerator. So the answer is 9/7. Okay, so the denominator must be the same. And it's going to be the same for the irrational expression. And in general, with a lot of these operations, for many operations, remember addition or multiplication, division have a set of rules. So that's when you cancel common factors and multiply through. And then addition and subtraction has a different set of rules. We need a common denominator. So let's look at this next example. And the instructions are to add. Remember, instructions are important. And when we add, the first thing we should look at is the denominator. And in this case, our denominator is the same. So that means we can go ahead and start doing our addition. So we keep the denominator and we perform the operation to the top. All right, and then it's plus 8, plus our other denominator. Okay, so we have to simplify our final solution. So our next step is always going to be to factor everything completely after we do the addition. So we're not done yet. The numerator is going to factor as x plus 4x plus 2, because 4 times 2 is 8, and 4 plus 2 is 6. And then the bottom is a difference of squares, x squared minus 4. A squared minus b squared. So we can do x plus 2x minus 4. All right. And then when we do that, we see we do have a common factor, so let's get rid of that. And then now we finally have our final answer. X plus 4 over x minus 2. All right. In similar situation, if we were to subtraction, we also need to have a common denominator. So let's look at this next example. So again, it's nice to focus on the instructions. The instructions are to subtract. Your next step, which should be to look at the denominators. And again, they're the same. So we are going to keep the same denominator. And we're going to do the subtraction to the top. Oops. Okay. And remember, since we want to subtract the entire denominator, we're going to have to put parentheses around that entire denominator. If we don't put the parentheses around, then we just are going to be subtracting the first term of that denominator. So it's important, I'm just rewriting it down here, it's important to use subtraction so we subtract the first term and the second term. Okay, so this is really 7c squared minus 2c squared minus a positive 10c over this. Okay, so we perform the operation to the denominator, and now let's simplify the top by combining like terms. And then let's go ahead and start factoring everything completely now that we've subtracted the numerators and simplified. What can we do to the top? We can take out a 5c. And then what can we do to the bottom? We can factor two numbers that multiply to -6 and add up to +1. And again, when we do that, now we're able to see the common factor. So let's get rid of that. And so our final answer is going to be 5c divided by c plus 3. All right, lovely. So let's go ahead and look at these next examples. you guys can do these on your own. You guys can push pause and then come back, look at the solutions. And notice we're adding and subtracting. And with adding and subtracting, we have to make sure that our denominators are the same. So that should always be your first step. All right, so let's push pause and then we'll see how you guys do. All right, welcome back. So all of these have the same common denominator. So again, the denominator stays the same, and you do the operation to the top. And once you do that, you factor everything completely and look for common factors. All right, in this first example, notice everything cancels in the top, and it's a good reminder that when everything cancels in the top, we're left with a 1. All right. Let's see what happens on the bottom. For number 2, did you remember your parentheses around that second numerator? Again, the parentheses make sure we're subtracting the whole numerator, not just one term. All right, so you simplify, minus a positive 6m, and then after you simplify, we want to make sure we factor everything completely, just as before. So factor the top, factor the bottom, and we do see a common factor. So it's 2m over m minus 1. All right, finally, let's see what we have for number 3. Again, we have a common denominator. Let's perform the operation to the top. It's subtraction, so let's remember our parentheses. All right, and then we can look at 3x squared minus 2x squared, 9x minus x, and minus a negative 15 for our numerator. And then now that everything is completely simplified, let's factor everything. And we do see a common factor. So x plus 5 over x plus 7 is our solution. All right, so the more challenging version of adding and subtracting is when we have fractions with unlike denominators. So let's look at this example, 5/12 plus 7/18. So when we did this in our arithmetic class, we wanted to find a common denominator, or the lowest common denominator. Sometimes it's nice to start with the bigger number, the bigger denominator, and start looking at multiples to see if the smaller ones go into it. So let's see, 18 plus 18 is 36, and 12 goes into 36. So that's the least common denominator. So to get 18 to go to 36, we need a factor of 2. So let's multiply 18 by 2, and to keep our fraction balanced, we'll multiply the top by 2. Again, that's like multiplying by 1, so we're not changing anything. And 3 times 12 is 36, so we'll do top and bottom by 3. And now our new problem becomes 3 times 5 over 3 times 12. Remember, don't simplify or else we're back where we started. And 7 times 2 over 36. And so our solution is 29 over 36. So again, with addition, we have to make sure our denominator is the same, and when we add, our denominator stays the same. So let's look at this example down here. So we're subtracting, definitely, and we notice now that our denominators are not the same. One is x to the 6th and one is x squared. So what can we get, or what can we do to x squared to get to x to the 6th? We can multiply it by x to the 4th. And whatever we do the top, we have to do the bottom. So x to the 6th is fine. That's going to stay the way it is. But now we're going to subtract 4x to the 4th divided by x to the 6th. So now we have a common denominator. Now we can perform the operation to the top. All right, there you go. And we can take this further. You guys can factor the top. If you want to write it in standard form, we see that we have to actually factor out a negative number. We can factor out a negative 2, 2x to the 4th minus 1. All right, it turns out we can't factor anything, so we can just leave our solution like that. All right, let's look at a more complicated solution where we have to add and subtract rational expressions and the denominators are not the same. So here we go. So we're going to add this expression. So first, we have to figure out what the LCD is. And it's not as simple as looking at 12 and 18. We have to factor everything completely. So that's your first step. So x squared minus 25 is the difference of squares. We can write that as x plus 5, x minus 5. And then x squared minus 5x, that's going to be x times x minus 5. I'm just lining up the factors so I can kind of easily see what our common denominator is going to be. Okay, so our LCD then has to have all the factors represented. So all the denominators can multiply into it. So LCD, it needs a factor of x. It needs a factor of x plus 5. And now x minus 5 happens once in each denominator, so we just need it once. And there's your LCD. So now in step 2, we are going to take our old expression, let's factor it completely, and we're going to make equivalent fractions. Okay, so let's see. In this first one, x plus 5, x minus 5, we're missing a factor of x. So we have to add x to make the LCD. So whatever we do to the top, we do to the bottom. And now the second expression, we're missing an x plus 5. Remember your parentheses. Okay. So let's multiply through to get our new expression, our equivalent expression. And so we are really going to be adding 3x over the LCD, just rearranging the order of the denominator. And we can do that because that's how multiplication works. Remember to distribute the 5 to both the 5x, or the x and the 5. We have to multiply the entire numerator by the entire factor. Okay, so now that we have that common denominator, we're in the same situation as before. Let's perform the addition and subtraction on the numerators. So we can write 3x plus 5x plus 25 over our LCD. And then let's simplify. So we can write that as 8x plus 25. And now we would factor everything completely and cancel any common factors. The only thing we could do to the numerator, since it's a degree 1 binomial, is to factor out a greatest common factor. We don't have that. So this is our final answer. This is going to be our final solution. Okay, so let's try this process on our own. So here we have 4 examples to do. Go ahead and push pause and we'll come back and see how you did. All right, let's see how it's going. Okay, so let's factor everything in number 1. All right, so it looks like we're going to need an x plus 3, x minus 3, and then an x minus 4. So our first one is missing an x minus 4, and our second one is missing x plus 3. All right, so you would get 2x minus 8, and then the next one would be 3x plus 9 over your LCD. Let's simplify the top. 5x plus 1 over your LCD. All right, the next one, we have to kind of imagine what the denominator is. It's going to be 2 over 1. So the common denominator is k plus 1. So we have to multiply top and bottom by k plus 1 to get the LCD. So 2k plus 2 plus our other denominator over k plus 1. So we have 3k minus 1 over k plus 1. All right. Next up, for number 3, our denominators look very, very similar. So before we actually do anything, let me go all the way down here to write some notes on this one. So remember, 6 minus x is the same as the opposite of x minus 6. Okay, we saw that earlier. So we could do this intermediate step where we switch the places of the negative x and the 6 and then factor out a negative 1. So if you'd like, you can rewrite it like this. And now we can kind of see how we have the same denominator. So 6 minus x is negative x minus 6. And then check this out. What can we do with minus minus? Minus minus becomes positive. So we didn't really have to manipulate our denominator too much in this example. We're going to end up with 8 plus 4, which is 12, over x minus 6. Okay, so a quick little hint or a quick nice little trick for that one. Finally, we have this one. This one's a little bit of a bigger problem. So let me rewrite the denominators fully factored so we can see what our LCD is. Minus. We have to be careful with minus signs. Okay. So let's fill in our missing factors. We are going to need an x minus 5, an x minus 2, and an x plus 5. So this first one is missing an x plus 5 from the top and bottom. That will make it the LCD. And our second one is missing an x minus 2 from the LCD. Okay, so let's see what that gives us. So x plus 4 times x plus 5, we'd have to FOIL that out. X squared plus 9x plus 20 minus 5 times x, and then minus 5 times negative 2. All right, so negative 5 times x is negative 5x. Negative 5 times negative 2 is positive 10. And then we have our LCD. All right, let's simplify the top. 9x minus 5x and 20 plus 10. Okay, and let's see, are there two numbers that multiply to 30 and add up to -4? Can we factor this? No, I don't think there's any special numbers. Remember, if you're ever stuck on a fraction or a trinomial that you're trying to factor, just remember you can always look at the discriminant, b squared minus 4ac. If it's a positive perfect square, you can factor it. Or if it's 0, you can factor it. So let's see, is -4 squared minus 4 times 1 times 30, is that a positive perfect square? No way. It's less than 0, so it's prime. We can't factor it. So that's how we know it's our final answer.